Module 6, Lesson 12. Lesson 12, Describing the center of a distribution using the median. How do we summarize a data distribution? What provides us with a good description of the data? The following exercises help us to understand how a numerical summary answers these questions. Example 1, the median, a typical number. Suppose a chain restaurant, Restaurant A, advertises that a typical number of French fries in a large bag is 82. The graph shows the number of French fries in selected samples of large bags from Restaurant A. Number 1. You just bought a large bag of fries from the restaurant. Do you think you have 82 French fries? Why or why not? No, I do not think it has 82 French fries because there are no bags with 82 French fries. This distribution has a lot of variability. Number 2, how many bags are in the sample? There are 20 bags in this sample, and this can be found by merely counting the dots on the dot plot. Number 3, which of the following statements would seem to be true given the data? Explain your reasoning. A, half the bags had more than 82 fries in them. B, half of the bags had fewer than 82 fries in them. C, more than half of the bags had more than 82 fries in them. D, more than half of the bags had fewer than 82 fries in them. E, if you got a random bag of fries, you could get as many as 93 fries. Well, I'm going to work with you on this problem, okay? You might have gotten all of these right. You may have gotten some of them wrong. But I would like to statistically show you how to calculate the median. That's the whole point of today's lesson. The most important thing to do when calculating the median is to order the numbers in your data set from least to greatest. Then you can cross one off at a time from both ends until you get to the middle. Now, the data set that we are trying to find the median number of has 20 points in it. That's an even number. Whenever you have an even number of numbers in your data set, you will always end up with two middles. You cannot have two medians. You can only have one. So when you have two medians, you have to find the middle of those two numbers, and you can do it mathematically by adding them together, which is 164, and dividing by 2 because you added two numbers together. You're really finding the mean. And the median, therefore, is 82. Okay? So now I can answer these questions presented a little bit more mathematically. Half of the bags had more than 82 fries in them. Well, let's see how many bags are over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Beautiful. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. The median has just cut this into two sides. This is called the upper half of your data, and this is the lower half of your data. So half of the bags had more than 82 fries in them. True. Half of the bags had fewer than 82. True. More than half of the bag had more than 82. False. More than half had fewer. False. If you get a random bag of fries, you could get as many as 93. Well, 93 is in our data set, so I'm going to say that is true. Example 2. The median. Sometimes it's useful to know what point separates a data distribution into two equal parts, where one part represents the larger half of the data values and the other part represents the smaller half of the data values. This point is called the median. When the data are arranged in order from smallest to largest, the same number of values will be above the median as are below the median. I pointed that, but I really wanted to underline that. They have to be ordered from smallest to largest. That is the most important part. So, this is exercise 4. Suppose you are trying to convince your family that you needed a new pair of tennis shoes. After checking with your friends, you argued that half of them had more than 4 pairs of tennis shoes, and you only had 2 pairs. Give another example of when you might want to know that a data value is a halfway point. Explain your thinking. I'm going to give you an example from me. Half of my friends get to go to the movies on Friday night. I should get to go too. Number 5. Use the information from the dot plot in example 1. The median number of fries was 82. What percent of the bags had more fries than the median? Less than the median? Your answer should have been 50% have more than 82, because 10 out of the total of 20 fries bags that we counted, and then I scaled it up to a percent over 100. That's going to be the same with the percent that is less than the median. It is also 50%. B. Suppose the bag with 93 fries was miscounted, and there were only 85 fries. Would the median change? Why or why not? Well, I'm going to cross off 93. And I'm going to put the new dot on 85. Okay? The median would not change because a move from 93 to 85 is still on the top 50% of the data. So remember what the median's job is. It's to cut the data in half so that there's the same number of data points on the lower end as there are on the upper end. So by moving 93, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of the 20 are still on the upper half of the data. So the median is still going to be 82. It's not going to change. Letter C. Suppose the bag with 93 fries really only had 80 fries. Would the median change? Why or why not? Well, let me take 93. Oh, let me go back. I can't. Don't read my answer. Mrs. Kramer's got to get better with her technology. Let me take 93, and now I'm going to move it to 80. Okay? I think it was right here. This median would have to change, and let me tell you why. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on this side. And now there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 on this side. I know why there's 10 on this side. I forgot to erase the one that I counted before. Let me double check that. Now, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 on this side, and 11 on this side. This is not a median, because a median is supposed to have the same on this side that as on this side. So let me read you the answer. Yes, the median would change because moving 93 to 80 would mean there would be 11 data values under the median and 9 above the median. It has to be 50-50. The owner of the chain decided to check the number of French fries at another restaurant in the chain. Here is the data for restaurant B. A. How many bags of fries were counted? There were 19. This is different from the first example, because our first example from restaurant A had 20, which was an even number, and it had 2 middle numbers. Since this number is odd, we'll only have one median. B. Sally claims the median is 75 as she sees that 75 is the middle number in the data set listed above. She thinks half the bags had fewer than 75 fries. Do you think she would change her mind if the data were plotted in a dot plot? Why or why not? So, Sally thinks that this 75 is the median. Is she correct? Yes, the numbers she is looking at right now are not ordered least to greatest, so you cannot calculate the median. If the data were in a dot plot, it would be ordered correctly from least to greatest, so the dot plot would help her calculate the median. But she's wrong right now because she did not order these least to greatest. C. Jake said the median was 83. What would you say to Jake? Well, if I was looking at the data, here's what I'd say to Jake. I don't think the median is 83 because there's 5 83s. Okay, there's 1, 2, 3, 4, 5, and there's also 185. And they actually look like the largest numbers in the data set, so there's really no way that that could be the middle. I do not think the median is 83 because there are 5 83s and 185. That would be a total of 6 numbers out of 19. The middle number will cut 19 in half. D. Betsy argued that the median was halfway between 60 and 85 or 72.5. Do you think she's right? Why or why not? I do not agree with Betsy because there is not a data value for every number between 60 and 85. You know, we had a 60, but we might not have had another number in that scale. So no, Betsy, you are not correct. E. Chris thought the median was 82. Do you agree? Why or why not? The first thing I would do with your partner is list the numbers like this in least to greatest order to calculate the median. If you calculate the median correctly, you will do something like this. There is only one median, and Chris is correct. It is 82. Calculate the mean and compare it to the median. What do you observe about the two values? If the mean and median are both measures of center, why do you think one of them is lower than the other? The median is 82. When you add all of the numbers together for the mean, you should have gotten 1,494. When you divide it by the 19 French fry bags that were counted, you should round your mean to the nearest tenth, which is 78.6. The mean is lower than the median because the lower half of data has more variability, therefore decreasing the mean. Number 8, a third restaurant, Restaurant C, tallied a sample of bags of French fries and found the results below. How many bags of fries did they count? All you really had to do here was count the tally marks. They counted 26 bags of fries. What is the median number of fries for the sample of bags from this restaurant? Describe how you found your answer. Again, I'll give you a shortcut or a hint. I would take these numbers and write them all down based on the tally marks in least to great order. 275, 76, 277, etc. Now calculate the median. If you do it correctly, now there's 26, so that's an even number. That means I'm going to get 2 middles. So I know what to do. I have to add them together and divide by 2. These are my 2 middles. 79 plus 80 is 159. Divided by 2 is 79.5. And if my middle median is not one of the data points, I always draw a line in between them and then cross these 2 out. Nine, Robert decided to divide the data into 4 parts. he found the median of the whole set. Okay, there it is, 79.5. Part A, list the 13 values of the bottom half. And those are these 13 values right here. Find the median of these 13 values. Okay, so you're going to do the same thing. Okay, but now you're going to find this half. There's a number here, 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 here. The median of the lower half is 78. List the values of the 13 values of the top half. Find the median of these 13 values. Okay, I'm going to move my screen. And I'm going to find the median of this half. Making sure I go side to side, side to side. The median of the upper half is 84. Which of the three restaurants seems most likely to really have 82 fries in a typical value? Explain your thinking. I think restaurant C would be the most likely to really have 82 fries in a typical bag because there is the lowest variability in the data. Thank you for listening to Lesson 12. Have a great day.